So, hi, my name is Seena. So, my project is called StreamHub. It's a high performance managed SciStream as a service. Uh, First, I'm going to talk about the introduction, what is scientific data streaming, motivation, challenges, and the solutions. Then a little bit of background. Then we will talk about the project. And finally, we will conclude it in the last section. So with the science advances, scientific facilities like accelerators or cyclotrons produce data at a high rate that exceeds the performance or availability of the common approaches, which are called like storage and post-processing approaches, and they are insufficient. Therefore, it also these experiments based on the experiment and the infrastructure or instrument can be really costly and can cost up to tens of thousands of dollars per hour. And the research facilities also usually don't have the enough computation infrastructure at the facility for analyzing or do computation on the results. So usually they are transferred to another facility such as HPCs. But for transferring these data, the common approaches which are batch-based workflows, are pretty slow. They need to store the data as they produced on the intermediate storage, and then these data is later transferred to the HPC. This adds a lot of latency, and to do the computation or analysis on this data, we need to wait. They need to wait for the transfer to be completed. The storage itself adds a lot of overhead and cost. And most importantly, we don't have the real-time analysis capabilities. So for example, since each experiments can be really costly, we might need to modify the experiment's variables parameters during the experiment before it finishes. But we won't have it with these traditional workflows. Therefore, RAM-to-RAM streaming were introduced as a solution where the data is transferred from the instrument as they are produced to the HPC and to do the computation at the real-time computations. So basically, we don't need any storing in the intermediate storage. So we have low latency and we will have high efficiency. Also, we will have the real-time processing, which will provide us with data analytics and experiment steering, which basically our project is basically about. It's an orchestrated, secure, high performance, and scalable streaming service. One of the prior works is called, which actually our project is based on, is called SciStream. It's a lightweight, secure, high throughput streaming framework, which basically it's a middle box architecture, which establishes gateway nodes on the science DMZs and establishes streaming channels between different facilities. It provides real-time processing and reduces the overhead and overcomes all the challenges that I talked about in the previous slide. But the SciStream has some limitations. Basically, and most importantly, it requires users' intervention and system modification. So user needs to be authenticated at each of different facilities to set up the gateway nodes. Also, for establishing the secure tunnels or channels, user need to modify the parameters. Since the user might not have root or administrative privileges in all of these facilities, the firewall rules should be modified to allow the user and the service to have internet access. Finally, it doesn't have any monitoring interface or availability, so we can monitor the network status and the data transfer. Therefore, our project, which is built on top of SciStream, provides uses Globus Auth for authentication. So we basically the user needs only to be authenticated through Globus Auth and no need to do authentication at each facilities. We also use Globus Compute to set up the gateway nodes at each facility and use the SciStream high performance capability to stream the data. This picture that you can see is basically the workflow of our project. The two red box on top and bottom are the two different facilities. One is where the data is produced, the bottom one, which we call it the produce network. And the top one is where the data will be processed, which we call it the consumer gateway, which is usually the HPC. So the user will go through, we have it has 4 stages. During the first stage, the user will be authenticated through Globus. Then we have the session setup, which the control plane of the system will initiate the SciStream, creates the keys and certificates, and transfer them to the gateway nodes. The gateway nodes where the Globus compute endpoints agents will start the SciStream services, and then we will create an inbound gateway node on the consumer facility, and the output gateway node on the producer. We have done more than 35,000 experiments on the Chameleon Cloud, and we had less than 2% overhead to achieve the near maximum capacity of a near line rate secure streaming. We also, during our experiments, we didn't have any CPU utilization more than 60% even when we had higher parallelisms. So as a conclusion, scientific discovery depends on these real-time computations and streaming. Common approaches which we are now basically are used are add latency and are insufficient. So we introduced StreamHub, which is built on top of SciStream and which provides a secure end-to-end high throughput streaming service.